Hello fellow physicists, today I'm going to show you how to work out time dilation. With that you can work out length contraction from the Lorentz transformations using only algebra and not the way with triangles. So in this, like you usually do, you start with two reference frames. So you have a stationary frame, which we're going to call S, and you have the moving frame or the prime frame, moving with a velocity v in the stationary frame. So to start doing anything like this, you need to have two events, okay? So you need to have two different things happening. So here, we've called them the sensor. The sensor emits and gets the light back from hitting the mirror. So since it emits a light beam, it hits the mirror, comes back, and it goes back to the sensor. So light is emitted from and returns to the sensor. So those are two different events. The emitting and the taking it back into the sensor are two different events. And because they're two different events, they have a time difference between them. So the sensor emits it, hits the mirror and comes back. There's going to be a time difference in between when it lets the light go and when the light comes back. So in this reference frame, in the moving reference frame, time difference is going to be called delta t0. And in the stationary frame, that time difference is going to be called delta t. But notice one thing, the sensor doesn't actually move. The sensor stays in the same place with reference to the moving frame. So we're going to come down here to the Lorentz transformations, which you have probably seen before in lectures. So since we're working with time, we're going to be working with this one over here. So what you need to do is you need to rewrite the equation, and all that we're doing is we're replacing t, t prime, and x, because those are the only things that are going to be changing, with delta t, the difference in time, delta t prime, and delta x prime. But the events, sending out the light beam and it coming back, happened in the same place in the f prime reference frame. So delta x, or the change in position, is 0 because the sensor didn't move. There is no change in distance in that reference frame. So what we can do is we can substitute this into this equation. So actually delta x prime becomes 0, and that simplifies to the equation that we need for time dilation. Excellent. Done.